All right, let's look at some examples of hypothesis testing. And we'll begin with an example of a test on a population mean. And the file that you can use to follow along is one called detergent. And in this case, we have a manufacturer of detergent who wants to check the validity of a claim. They want to test a claim that each box of detergent, on average, contains more than 500 grams of detergent. So there's a manufacturing line and they're producing detergent, and they'd like to be able to make a claim that on average their boxes of detergent all contain more than 500 grams of detergent. But they'd like to test this claim, so they take a sample of boxes of detergent, and based on this sample, they want to see if the evidence from this sample supports that claim. So in this case, the alternate hypothesis statement would be that the mean is greater than 500 grams. And the corresponding null hypothesis statement would be that the mean is less than or equal to 500 grams. We'll do this test with a standard significance level of 5%. And because we're doing a test on a population mean, this is going to be we'll model the sampling distribution with a t-distribution. So our test statistic will be the t-value. We'll find out what the mean amount of detergent in our sample is, and if it's greater than 500, what we want to know is how much greater than 500 is it? How many standard errors above 500 is it? Is it so far away that we have to conclude that the population mean is something greater than 500? So to do that, we'll find the t-value for our sample and the corresponding p-value. And we'll work on that in Excel, and we'll see how it looks. So here's our data file detergent, and I'll zoom in here to give us a better view. And we have a number of boxes of detergent. Scroll down, we've got 100 boxes of detergent in our sample. And for each box of detergent, we have the number of grams of detergent that's measured in that box. So we can start to capture some information that will allow us to ultimately find the p-value for our test. So first of all, our sample size is 100. Our sample mean will be the average of our amount of values in column B here. So equals average, and select my amount of values. And my sample mean is 524. So that's greater than 500. That's a good thing. If the sample mean came out to be anything less than 500, then there's absolutely no way the evidence could support the claim. So it's on the right side of our null value of 500 to help us. We'll want to know how far away it is, though. So let's just go ahead and put our null value in here as 500 grams. Here. So let's calculate the sample standard deviation equals STDEV. And again, I select my values under the variable amount. Control Shift down arrow. Okay, so STDEV of my column of detergent amounts, and I get a value of 76 grams as my standard deviation from my sample. My standard error now is going to be that S divided by the square root of my sample size. So my equals sample standard deviation divided by the square root of my sample size, the square root of 100. And I get a standard error of 7.62. All right, so the question is, how many standard errors is my sample mean above the null value? And we can find that out fairly easily. So that t-value is going to be the sample mean minus the null value divided by the standard error. Now we find out that this sample mean is just over 3 standard errors away from the null value, just over 3 standard errors above the null value. So intuitively we start thinking this is a fairly significant amount of distance away from the null value, but we can quantify this really well using the p-value. We want to know what's the probability of a random sample from a distribution centered at 500 being at least as far away as this sample and that we have that has a mean out at 524. So we're going to find a probability under this t-distribution. So we're going to use our t-dist function, and we want to know the probability of getting a t-value greater than 3.1967. So I'm going to say equals t-dist. And the first thing it wants is this positive t-value. So I'm going to put in my t-value. Then it asks me for the degrees of freedom. That's going to be my sample size minus 1. So my t-value, comma, and then sample size minus 1 is going to be my number of degrees of freedom. And then it wants to know, do I want the probability just out in one tail of the distribution or in both tails of the distribution? And that'll correspond to whether this is a one-tailed test or a two-tailed test. And in this case, because the claim was that the average amount of detergent was greater than 500, this would be a one-tailed test. So I'll put a 1 in as the last argument in my t-dist function, and I get a very small value of 0.00093. So this is going to be our p-value for the test, and we're going to compare this to a standard significance of 5% or 0.05. And obviously this p-value is much less than 0.05, so we would reject the null hypothesis and say that to a 5% significance, the evidence from this sample strongly supports the claim that the mean of all of the boxes of detergent, right, the population mean for the box of detergent is greater than 500 grams. So that would be our real-world conclusion that we derive based on our p-value and the fact that it caused us to reject our null hypothesis. Okay, well, let's take a look at another example. In this case, we want to do a test on a population proportion, and the data file that you'll use here is one I've posted for you called Colgate.xlsx. And here we have a large retailer, say a company like Walmart, and they want to test a claim that market share for Colgate is below 20% among all toothpastes. And so they want to know what the population proportion is. They want to test a claim that the population proportion is somewhere below 20% for the entire population of all, let's say, all Walmart customers. So they've gone out and taken some representative sample of Walmart customers, and they want to use that sample to see if the data supports a claim. So our alternate hypothesis statement here would be that the population proportion is less than 20%. That would reflect the claim that they want to test. And the null hypothesis statement would be that the population proportion is greater than or equal to 20%. Again, we'll use a standard 5% significance level. And because we're doing a test on a population proportion here now, we know that we can model this sampling distribution using the z-distribution. So we're going to find the same thing. If our sample proportion ends up being less than 20%, we'll want to know how many standard errors is it below 20%. And we'll measure that in terms of a z-value and then find the corresponding p-value using our norms dist function. So let's take a look at the data set. And here we have a number of customers, and in this case they've selected a sample of 200 customers, and in each case the customers were asked what their preference was in toothpaste. So you have this listing of values: Colgate, Mentadent, Crest, Colgate, etc. Others, which includes a variety of other brands. And what we'd like to know is, from this sample, what's the proportion of customers, the proportion of observations that recorded Colgate as the preference. So we can start to capture some information here. Our sample size, as we saw, was 200. Our sample proportion is one that we'll need to find out. So the key is we have to identify how many times we have Colgate appearing in this list, and there's a variety of ways we can do that. One simple way is actually to use a pivot table. So I'll show you that one. We can insert a pivot table. I've selected just one cell within this original columns of data. So I'm going to create a pivot table, And in this pivot table, I'm interested in counting up preferences. So I'm going to take preference and put it in my row label. And then I'm going to take preference again, put it in my values label. And because it's an alphanumeric or a categoric variable, it defaults to a count. So I automatically get a count of the occurrences of each one of these separate values under my column preferences. And as I can see, there are 31 observations where Colgate was recorded as a preference out of 200. So my sample proportion is going to be this 31 divided by 200. So let's go back and capture that. Sample proportion is 31 divided by my sample size, which is 200. So I get 0.155 or 15.5% as my sample proportion. Now, this is below 20%, so there's a chance that it's far enough that it could support the claim that the market share, if you will, of the entire the entire population proportion is statistically significantly below 20%, but we'll have to go ahead and calculate this to see if it really is statistically significant. So our null value, our null proportion value is 20% or 0.200. And our standard error, which we'll need, is going to come from the function that we've already shown, which is going to be the square root of the null proportion times 1 minus the null proportion, all divided by the sample size. And again, that's all within the square root. So SQRT of, and then first I'm going to take my null value. It's important to remember here to use the null value and not the sample proportion, the null proportion. So I'm going to say null value times 1 minus that same null value divided by my sample size, and all of that is going to be within my square root function. And I get a standard error of 0.028. All right, so now I want to ask and answer the question, how many standard errors is this sample proportion below the null value? So I'll say equals, open parenthesis, my sample proportion minus my null value divided by the standard error. And I get a z value of a negative 1.591. Negative 1.59099. So it's moderate. It's 1.5 standard errors away. So let's go ahead and calculate the p-value so we can determine, at least to a 5% significance, whether or not we could say the data supports the claim. So what I want to find is the probability under this standard normal distribution, under this z distribution of a random sample having a z value that is at least as far away from 0 as the z value I have here. So what's the probability of a z value being less than a negative 1.59? And I can say, again, it's just a matter of manipulating that norms dist function. But one of the ways I can do it is to say norms dist. It's important to remember the S here for the standard normal distribution, which is the z distribution. So norms dist of this negative, this z value that happens to be negative. So that'll give me the probability of being at that value or further to the left, at that value or further below, which is in this case is more extreme. And I get a p-value of 0.05581. And here again, as always in a hypothesis test, we're going to compare our p-value to our significance level and ask the question, is this p-value less than a 5% significance? Is it less than 0.0500? And as we look at the numbers, we'd have to conclude that it is not less than 0.05. Therefore, we would not reject the null hypothesis. We would have to say that the data is not sufficiently strong for us to conclude that Colgate's market share among Walmart customers is less than 20%. We could not conclude, we could not support the claim that the population proportion is less than 20%.